Alright, we're gonna go over the homework on page 478. I'm just gonna run through the problems real quick. So it's page 478. I'm gonna try to run through all of the problems. Just watch and see what you get, or see what you had. The first one says, draw a figure on the coordinate plane in quadrant 1. So I'm gonna draw something in quadrant 1, just a little triangle there maybe. Rotate the figure 90 degrees clockwise, and then you're gonna do the same thing to the figure 90 degrees counterclockwise and see what happens to the coordinates. Let's just make up some coordinates here. We'll call that coordinate 2, 3. I'm gonna call this one 1, 1. This one 5, 1. So we've got those coordinates. We want to rotate at 90 degrees clockwise, so we're going to go around that way. The rule for 90 degrees clockwise is XY. Just look back at your rules. Goes to Y, negative X. So you switch them and take the opposite of the second one. So our points, our new point, this point right here is going to go to, you switch them around, it's going to go to 1, negative 1. So it's going to be right here somewhere. This 2, 3 is going to go, switch them, it's going to go to 3, negative 2, so somewhere about right in there. And the 5, 1 is going to go to 1, negative 5, so 1, somewhere about in here, negative 5. Alright, so this is 1, negative 5. This is 3, negative 2. And this is 1, negative 1. Now they want us to do the same thing, but going the other direction. Going counterclockwise, so this way. So the rule for counterclockwise is XY goes to, for 90 degrees, negative Y, X, you switch them around and take the opposite of the first one. So if I'm looking at my original coordinates over here, I'm not going to write them down over there, just looking over here. So you switch the 1 into 1, and then you take the opposite of the first one, so it'll be negative 1, 1. The 2, 3 is going to be, switch them, it'll be negative 3, 2. And then the 5, 1, you switch them, and it's going to be negative 1, 5. And what they want you to do is look at these ordered pairs and compare them to these ordered pairs. Well, if you look at those two compared to each other, these two compared to each other, these two compared to each other, all they are is each X and each Y is the opposite of the other one. Number 3 says compare and contrast translation, rotation. Translation's a slide. A rotation is actually a turn, so that's one way that they're sort of different. With a slide, the shape's always going to be pointing the same direction, so on and so on. With a turn, it could actually be pointing a different direction. Something that they're having in common, or they're the same with, is they're both, no matter what happens when you get done, they're going to be congruent to each other, which we talked about last time, or 2 times ago. They're both isometric transformations, because when you get finished, the original shape and the new shape are congruent to each other. Number 4, they want us to rotate this shape about point G. Again, this is one of the harder ones. They want us to do it 60 degrees, rotate it 60 degrees, counterclockwise. So again, what you have to do, sort of figure out what a 60-degree angle is. That's about a 90-degree angle, 60-degree angle, maybe something about like that. And we're not going to be exact with this. If I could write 60 degrees on there, that's a 60-degree angle. We're going to connect point B to it. We want to go 60 degrees counterclockwise, so we're going around this direction. So we want about a 60-degree angle. Down this way somewhere. Sort of measure how far B was originally from G and put it that same distance from G. So B prime is going to be somewhere about in there. Do the same thing for D. We want 60 degrees going this direction. Maybe, that's probably too much. Maybe 60 degrees is about there. Take D up to there and fall somewhere about in there. So that's D prime. We do the same thing for C. Missed it by quite a bit. We want to go 60 degrees this direction, so that might be about 60 degrees. Measure it. We want C prime to be the same distance from G as C was, so somewhere about in here. Just use your pencil or whatever finger to measure it out. And I'm going to change colors here real quick. Let's go with black. Our shape. Comes out looking something like that. And again, we're not going to be exact with those. We're not going to get out a ruler and a protractor, but things I will look for. Did you go the correct direction? Did the shape stay the same size? And did you go about the correct angle? So did you go about 60 degrees in this case? So it should be somewhere about in there. Next, they want us to rotate this. This is number 7. They want us to rotate this segment 45 degrees clockwise about the origin. 45 degrees clockwise. Well, 45 degrees is half of a right angle, and we're using the origin. So we're just going to tether it or connect it to the origin there. So Y is going to go about 45 degrees. Well, this whole thing right here is a right angle, so about half that's going to be 45 degrees, and we want it to come out to be the same distance. So somewhere right about in there, that's going to be Y prime. X, we tether it to the origin, and we want to go out about 45 degrees. Well, 90 degrees would be somewhere about in here, so about half of it is going to come somewhere up through there. That's about 45 degrees, and we want it to be the same distance from the origin as the original X was. So it's going to fall somewhere maybe like right in there. That's going to be X prime up there, and that's our new segment. Again, you're not going to be exact on that. Number 8, they want us to go 90 degrees clockwise about the origin. First thing I'm going to do, write in these ordered pairs. That one looks like it was supposed to be -1, 8. This one looks like it was supposed to have been 4, -2. And this one was supposed to be right there, I think. And it was supposed to be 2, 4, 6, 7, -7, -4. All right, so we have that. We're going to take those points, -1, 8, -7, -4. You got to use your rules. You guess it or estimate it or anything else for, if you're on a coordinate system and you're going about the origin, you gotta use your rules. And the rule for 90 degrees clockwise is you switch the X and Y, and then you take the opposite of the first one. And this isn't supposed to be clockwise, this is for number 8, it's supposed to be counterclockwise. Says under rotation counterclockwise, I just forgot to write it in there. So this is the correct rule for counterclockwise, I just forgot to write counter in there. So we switch them, take the opposite of the first one, so that's gonna be -8, -1. This one's gonna be 4, -7, and this one's gonna be, switch it, and it's gonna end up being +2, 4. Now we graph each of those. Let's do it in a different color. Let's do it in blue. So we go -8, 2, 4, 6, 8, -1. That's gonna be P prime. 4, -7, 1, 2, 3, 4, 4, -7, 2, 4, 6, 7. That's gonna be R prime. And 2, 4, 2, 4, be right there, and that's gonna be Q prime. This is probably the only one on the page that was a normal one. And we'll do more of these today, but that's what your shape should look like. Rotating at 90 degrees about the origin for number 8. Number 9, they want the order of a regular hexagon. Hexagon has 6 sides, so the order is just going to be 6. The magnitude is 360 divided by 6, which is 60 degrees. Remember, the magnitude is how much of a turn you make each time it looks exactly the same. A regular octagon, the order is going to be 8. The magnitude is 360 divided by 8. 8 will go into 36 4 times with 4 left over. 8 will go into 40 5 times. So the order for an octagon will be 8 and the magnitude would be 45. Number 11, looking at those fans. The first fan, the order, is going to be 5. The magnitude then is 360 divided by 5. 5 will go into 36 7 times with 1 left over. So 72 is the magnitude. The second fan, the order is going to be 4. And you want 360 divided by 4 for the magnitude. That's 90. The third one, the order is going to be 3, and then we want 360 divided by 3, which is 120, so the magnitude is 120 degrees. Those are the answers you should have for number 11. Number 12, another one of the hard ones, they want you to rotate this 110 degrees counter clockwise. That means we're going to be turning this direction about point R. Change my pen color here. Let's go with the light color and we'll draw this in. So let's just start with B. We connect B to R, 110 degrees. 90 degrees is about that much, 110 degrees. It's going to be a little more than that, so maybe something about like that. That. About 110 degrees maybe. So we want to go counterclockwise. So we're turning it, and you got to be careful, I drew that up here, but we're turning it this way, going around. So this is going to come out this way. We want to go 110 degrees. That'd be about 90, so 110, somewhere about in there. Might be a little more than that. Measure, we want B prime to be about the same distance from R as B was. So B prime somewhere about in there. Then let's do F. See how this comes out. May come out looking sort of ugly. On 110 degrees off of that, 90 degrees would be about there, so 110, maybe somewhere about in there. F, measure it, go about that same distance. F prime, gonna end up falling somewhere about in there. Let's do E, somewhere there, 110. 110 degrees, gonna come out somewhere about in here. Again, you're not gonna be exact with this, but you wanna be fairly close. We still want the shape to look like a pentagon when we're done. And fall somewhere way out here. That's gonna be E prime. C prime, let's jump over here. Not that far, we're gonna come around this way. That looks like that's about 90, so I'd say C prime. Somewhere about in there maybe. And then the last one, D prime. Going up to R. I want it to be about 110 degrees. Let's see, that'd be about a right angle, so 110 degrees. Somewhere about here maybe. That's going to be D prime. We want it to be the same distance. Not this far. Now hopefully we connect all those and it looks somewhat like a regular pentagon like we had to start with. And then let's change our ink color here and go with red. Yeah, it's a little off, but it's not too bad. So we turned it 110 degrees that direction. Looks like my F probably got off a little bit. It's probably supposed to be back in here a little more. Or maybe my E was off a little bit. It should be down here a little more. Something like that. Same idea on this one. This one they want us to go 180 degrees clockwise, 180 degrees a little easier. I connect this to there. It's going to go 180 degrees, so it's just going to make a straight angle out through there. Want to be the same distance from N to Q. So somewhere about here is going to be N prime, M. Come right down through here, if I could ever draw anything straight. And it's actually going to come on down this way. Want it to be the same distance. So about this distance. That's going to be M prime. 180 degrees a little easier because we don't, the straight angle should just be a straight line. P. See how well I can do this. Probably not very well at all. Off. P's gonna come. Hopefully that's sort of straight. You can maybe use the straight edge, the edge of your book or something like that to get that so that you're making it a little straighter than what mine is. It's gonna be, we gotta measure it out. P's quite a ways from Q. Hopefully I can fit it on the screen out here. It's gonna be P prime. Our shape looks something like that. Looks like maybe I got M down a little far. M should probably be right about here maybe. It's not too bad though. It's about the same. It's rotated 180 degrees counterclockwise, so we actually turned it this way. Doesn't really matter which way we turned it, it's going to end up the same spot either way. We're going to skip 14 and 15. Those are Same idea as the last few, you're just on a coordinate system, and you've got some shape and you're going around some point. So you're just doing the same thing as we just did, going 90 degrees or 60 degrees or whatever they tell you. 16, problem 16 says identify the order and magnitude of symmetry for the 20-seat Ferris wheel in the picture. Well, the order is going to be 20, the magnitude 360 divided by 20, you can cancel out the zeros there, and then 36 divided by 2 is 18 degrees. Number 17, what is the measure of the angle of rotation if seat 1 is moved to seat 5 position? So if you look where seat 1 is and you move it to the 5th position, you're moving it 1, 2, 3, 4 angles there. So it's going to be 4 times, each one is 18. So 4 times 18. You're not moving at 5 positions, so make sure you don't make that mistake, because you're going from 1 to 5, not 0 to 5. So 4 times 18, 4 times 8 is 32. 72 degrees is how much you turned it. If you turned it 144 degrees, where would seat 1 be? So if you turned it 144 degrees, you want to know where seat 1 is going to fall. Well, the way we can figure that out is take 144 divided by 18. 6 times 8 is 48, that's too much. 5 times 8 is 40, 7, 6 times 8 is 48. That's not too much. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. So that means the seat's going to move 8 positions. Well, if you go back and count on your Ferris wheel, if you move seat 1 8 positions, you would be in seat 9. All right, problem 22, they want us to reflect this over the y-axis, then the x-axis. Easiest way to do that is probably just count, since we're on the axis already, to go over the y-axis. T prime is just going to stay in the same spot. U is 2 places from the y-axis, so it's going to come over here 2 places. That's going to be U prime. V is 1 space from the y-axis, so it's going to come over here 1 space. That's V prime. That's our first one. Remember, when you do 2 things, this is called a composition. You're doing more than 1 movement to the shape. Now we're going to reflect it over the x-axis. The T is 4 spaces above the x-axis, so it's going to be 4 spaces down. That's going to be T double prime. The V is 2 spaces above, so it's going to be 2 spaces down. That's going to be V double prime. And the U is 3 spaces above, so it's going to be 3 spaces down. Oops, that's U double prime. And our shape, our final shape, looks something like that. Could have done it in a different color, I guess. This one, they want us to reflect it over y equals x and then the x-axis. Remember, y equals x goes right up through here, so it's a line, goes something just like that. So we're going to reflect it over that, and then we're going to reflect the new shape over the x-axis. When you go over y equals x, you just have to remember your rule. If you look back at your notes or flip back in the book to reflections, that was 9-2. should be able, or 9-1, I mean, that, you should be able to find the rule. And for y, y equals x, it goes, x goes to, and in the book it uses a and b, doesn't matter. All it does is switch the order of the coordinates. So we need to find the coordinates for each one. M has coordinates of -2, 4. L has coordinates of 2, 4. And K has coordinates of 1, 2, 3, 4, 5, 0. And all we're gonna do is switch those around to get the new ones. So M prime is gonna be 4, -2. L prime is going to be 4, 2, and K prime is going to be 0, 5. When we graph those, I'll use it, we can use red, I guess. 4, 1, 2, 3, 4, -2. Hopefully I don't count wrong. 4 positive, that was M prime. 4 positive 2, that's L prime. And 0, 5, 0, 2, 3, 4, 5, that's K prime. So going over that red line, that's what it looks like. Then we're going to take that shape and reflect it over the x-axis. So we're going to take the red shape. I'm going to change my ink color here. Let's go with purple this time. To go over the x-axis, it's easiest just to count. M is down 2 spaces over the x-axis, so we're just going to go up 2. So M double prime is going to be there where L prime was. K is 5 spaces above the x-axis, so it's going to be down 5. So that's going to be K. Oops, that's wrong. Yeah, no, that's right. That's going to be K double prime. I couldn't see my prime up here. And then L was 2 spaces above, so it's going to be 2 spaces down. So it's going to be right where M prime was. And now this purple shape is what the shape looks like after we did the composition, after we did both movements. Number 29, they give you some pictures there and they want to know, for each ride, determine whether the ride undergoes a rotation, just write yes or no. So the teacups, yes. The scrambler, yes. The roller coaster, no. They wanted capital letters. Number 32 wants to know all the capital letters which produce the same letter after being rotated 180 degrees. If you just go through your alphabet, H would, I would, N would, O would, P won't, Q, R, S will, T won't, U, V, W, X, X will, Y, no, and Z will. So those 7 letters. 34, if a rotation is performed on a coordinate plane, what angles of rotation would make the rotation easier? So if we're on a coordinate system, which ones are going to make the rotation easier? Well, 360 is most definitely easy. Um, 90 is not too bad, and 180 is not too bad. 270 you could put on there also. So it's all those nice even ones instead of like 60, 50, 40, any of those 110, any of those don't make it easy. 35. Quadrilateral QRST is rotate 90 degrees clockwise about the origin. Describe the transformation using coordinate rotation. All they wanted there was the rule. Well, for 90 degrees clockwise, you go XY goes to, for 90 degrees clockwise, goes to Y negative X. That's all they wanted on that. Probably made it seem like it was a lot harder than it was. All right, on this one, they ask us, in the figure, describe the rotation that moves triangle 1 to triangle 2. So they want to know how much you're actually turning it. Well, we have 1, 2, 3, 4, 5, 6, 7. I forgot where I started at. Let's put a mark there. 1, 2, 3, 4, 5, 6, 7, 8 sides. So we can find the order, which in this case is going to be 8. And then we can also find the magnitude, which is going to help us to figure out how much we actually turned it. 360 divided by 8. 8 will go into 36. I think we already did this once on these. 8 will go into 36 4 times with 4 left over. 8 will go into 45 times. So each time you're turning it 45 degrees. So if I moved angle or position 1 to here, I turned it 45 degrees. If I moved it here, I turned it another 45, which is a total of 90. Turned it to here and I moved it another 45. So 3 times 45, which is 15, 135 degrees. That's how much I turned it. And that would be answer C, because we turned it 135 degrees counterclockwise. So the answer would be C. (42), they give you some algebra. Says X is 2/5 of Y. So X is 2/5 of Y. You got to remember from algebra that is means equals and of means times. I've already sort of wrote that out here. And then they did the same thing for Y. They said Y is 1/3 of Z. Well, they tell us X is 6, so if I come back here and I stick 6 in that place right there, got 2/5 times Y. To get rid of the 2/5, all you do is multiply both sides by the reciprocal, which is 5/2. These are going to cancel, these are going to cancel. Whatever you do to one side, you got to do the other. So you multiply this by 5/2. On the right-hand side, we're left with just Y. On the left-hand side, when you multiply a fraction times a whole number, you multiply times the top, so you times up there, and then you divide by the bottom. So 6 times 5 is 30, divided by 2 is 15. So we now know Y is 15, and we can stick that in right there, substitute it in, and you get 15 equals 1/3 times Z, but we're going to do the same thing here. Multiply both sides by 1/3. These are going to cancel. Oops, not 1/3. Multiply both sides by 3/1 by the reciprocal. These are going to cancel out. These are going to cancel out. On this side, 3/1 is just 3. So you're just going to multiply 3 times 15, which is 45. That's what they ask us to find. Hopefully that's one of the answers down there. That was letter D. All right, what we're going to do next is go over the worksheet that's just one page. It sort of says 9-3 on the side. It's only got 6 problems on it. So, it's just got 6 problems on it. And I'm just going to go over it. It's talking about rotations. We're going to go through that. And then your assignment, part of your assignment is going to actually be to do the other worksheet. But then we're gonna try to also get started on the next setup. So hopefully you can figure out which worksheet I'm talking about, and I'll get this drawn and they'll get passed out. The first problem has a triangle that's SWT. S is 2, 1. T is 1, 2, 3, 4, 5, 1, 2, 4, 5, 1. And W, thanks, switching on me. W is 3, 3. Hopefully you got that worksheet by now. Either I passed it out or the substitute passed it out. And this first one says they want us to go 90 degrees counter clockwise about the origin. Remember, you gotta know those three things every time you're doing a rotation. You gotta know your angle, you gotta know your center, and you have to know your direction. Remember, this is your angle, this is your center, this is your direction. Now I got them in the wrong order, but so we want to go 90 degrees counterclockwise. The rule for 90 degrees counterclockwise, if you look back at your rules, 90 degrees counterclockwise is XY goes to negative Y, X, so you switch the order and change the sign of the first one. So if we just look back at these points, W was 3, 3, and you should do this every time. T was, should write out the ordered pairs, 1, 2, 3, 4, 5, 1. And S was, hopefully I didn't count wrong on these when I graphed them, 2, negative 1. And we want to go to W prime, T prime, and S prime. 1 second. All right, starting over back on this problem. Just give me a second and I'll regraph it. S was 2, negative 1. I'll write it down over here while we go. S was 2, negative 1. T was 5, 1. And W was 3, 3. So that's our original triangle. I know I turned the points around. I hope that doesn't mess anybody up. We want to go 90 degrees counterclockwise this time. So 90 degrees counterclockwise. And the rule for 90 degrees counterclockwise is XY goes to, counterclockwise is it goes to negative Y, X. So S prime is going to be, let's change colors here so we can write this in different. Let's go with the orangish looking color here. S prime, we're going to turn it around and then change the sign of the first one. So 1, 2. T prime is going to be, turn it around. That's going to be a negative 1, 5. And W prime is going to be, we turn it around, that's going to be a negative 3, 3. Remember, for this one, you turn it around and you take the opposite of the first one. We graph that, 1, 2, that's S prime. Negative 1, 5 is T prime. And negative 3, 3 is W prime, and our new shape, rotating at 90 degrees, counterclockwise, looks something like that. Make sure we went the right direction. That's counterclockwise, so it looks all right. at any point I go too fast, could just hit pause or something on the video. The next one is number 2 on the worksheet. I'll draw it up here real quick. Again, this is the one-page worksheet. It's just got 6 problems on it. Just wanted to go back through to give some examples. They tell us that D is -4, 3, and E is 1, 2, and F is -3, -3. I'll graph that real quick. -4, 3. That's D. E is 1, 2. Right there. And F is -3, -3. Right there. So hopefully that looks something like the one that they gave you on the picture. And this time we want to go 90 degrees clockwise. The rule for 90 degrees clockwise is XY goes to, you can look this up in your notes again, switch the order, and change the sign of the second one, take the opposite of the second one. So let's change our colors here. Let's go back to red. So D prime is going to be, we switch them around, take the opposite of the second one, so it's going to be 3 and a +4. E prime is going to be 2 and a -1. And F prime is going to be -3. Switch the sign of the second one, so +3. Those are all primes. So 3, 4. I'll be right about there. That's D prime. E prime is 2, -1. And F prime is -3, 3. I missed my point. So when we rotate it 90 degrees clockwise, going this direction, it's going to look something like that. And again, that's about the origin, rotating it about the origin. Next one, number 3 on there. It says, draw the rotation image of the figure in the given direction about the center point. So about, I'm going to change one of these. The first one, number 3, I'm going to do about the origin, and number 4, we'll do it about the point that they gave us. We'll talk about that when we get to number 4. They give us these points for number 3. R is -3, 3. S is 2, 4. And T is 1, 2. And this time we want to go 180 degrees. I changed it to 180 degrees clockwise. And we're going to go about the origin. Let me graph that real quick. -3, 3. Be right about there. That's R. 2, 4 is there. That's S. And T is 1, 2. So our triangle should look something like that. Hopefully that looks like the one that they gave us on the picture. And we want to go 180 degrees clockwise. So we look up 180 degrees. Remember the rule for 180 degrees, whether you go clockwise or counterclockwise, is the same thing. So XY goes to -X, -Y. So R prime is going to be, we just take the opposite of both of them, so +3, -3. S prime is going to be -2, -4, and T prime is going to be -1, -2, you leave them in the same order, but take the opposite of both the x and the y. So 3, -3, 3, -3 is gonna be somewhere about in there. That's r prime. -2, -4, somewhere about in there. That's s prime. And -1, -2 is t prime. Our shape's gonna look something like that if we rotate it 180 degrees. And it says clockwise, but it doesn't really matter which way we took it, because either clockwise or counterclockwise, we're gonna end up in the same spot. Number four, I'm gonna change a little bit. Let's change the color on this. On number 4, I originally changed it. It was rotated around -1, -1. I want to go ahead and do it that way. I changed it to the origin, but we're going to change it back to using that -1, -1. And they tell us that H is 3, 1. J is 3, -3. And K is -3, -4. Let's hope I can do this right. We're gonna rotate it. This is our center. That's what we're gonna rotate it around. Center, and messing up. Center. And we're gonna rotate it 180 degrees. Counterclockwise. Go ahead and graph the original 3, 1. That's H. 3, -3. That is J. And K is -3, -4. Hopefully that looks something like the shape that they gave us originally. And the point that we want to rotate around is -1, -1, so that's right there. That's our point. They call it point P. Go with a light color this time. All right, since there's no rule to rotate it around some point like -1, -1, we just sort of have to do the same thing. This one's not too bad because we're going at 180 degrees, so we have to do the hard thing. We're going counterclockwise, so that means we're going that direction. If I connect P to H, I want to go 180 degrees. That means it's going to come out here somewhere. We want it to be a straight line there. Sort of measure about how far P is from H, and again, we could be a little more precise on this, but for now, we're not going to worry about it. So H prime is going to be somewhere about in there. We do K. I'm going to go straight up through there. I can make a straight line. Again, remember all lines are straight, so I shouldn't have said that. And K prime is going to fall somewhere about in there. Then J. I don't know if they do that right. Going this way. And J is going to go straight through here. Going to be about the same distance up there. Just take your pencil, finger, whatever, measure about the same distance. That's going to be J prime. We'll change colors here so that we can draw it in. Just go with black this time. The shape looks something like that. Mine doesn't look exactly right. Looks like this should be up a little higher maybe. Something about like that. And we went around this point right here in the middle. And we went 180 degrees. counterclockwise, which it didn't really matter. If we went clockwise, we ended up with the same thing. The next one, which is another number 1 on there, we don't really need the coordinate system. So I'm going to do this real quick. All right, the last 2 on this worksheet. The first one says "90 degrees counterclockwise," and it gives you a shape, looks something like this. This is Q, P, S, and they put R somewhere about there maybe. Remember, these are the ones, we're not gonna be exact on these, but we're gonna try to get as close as possible. Let's change our ink color here. Go with purple. We want to go 90 degrees, so 90 degrees isn't as hard because you know a right angle has to look like that. Has to form that little square there. So we want to go 90 degrees counterclockwise, which means we're moving this way. We connect R to Q, and we go 90 degrees counterclockwise, come down this way. Means it's going to come straight down here somewhere. We sort of measure how far Q is from R. Measure it again. A little bit. So Q prime is going to end up being somewhere right in there. Connect P to it. I'm going to go exactly 90 degrees. And probably a little far. Somewhere about in there. P is a little farther. P is a little farther in. P is going to be somewhere right about in there, P prime. And then S, we want to go 90 degrees off of that, not too much. Make a right angle right here. And it doesn't look like a right angle a whole lot, maybe somewhere up here a little bit. Measure how far S is from R. S prime is going to be somewhere right in there. Hopefully we connect these, and our shape looks about like the original, but it's been turned 90 degrees counterclockwise. The last one on this says turn 90 degrees clockwise. 90 degrees clockwise. It gives us a shape that looks something like this, looks like a parallelogram. And they put R somewhere down in here. There's G, K, J, H. And they want us to go 90 degrees clockwise. Again, 90 degrees isn't too hard. Just change our colors here. Let's go with the light color to draw in our line. We want to go 90 degrees clockwise, so now we're going that direction. Connect H to R. 90 degrees clockwise means we're going to turn out this way. And we want a 90 degree angle there. I'm going to measure how far the original H was from R. We go out about that far on our new ray here. So somewhere about in there maybe. That's H prime. Connect J to R. I go 90 degrees, which looks like it's almost straight up and down. Go about that far. So somewhere about in there, that's going to be J prime. Connect K to R, go at what 90 degrees, looks like it's just about right along that same thing. A little farther away. Maybe somewhere about here maybe. That's K prime. And then G to R, go 90 degrees, somewhere about in there maybe. You can almost tell on this one if I'm doing it completely wrong or not. Let's change the color so we can actually see it. Change it back to red. Not real bad. So we turned it 90 degrees clockwise. All right, what we're going to do next, if there's time in class, what I want to do is go on to the next notes. So we're going to write these next notes. Not that, we'll do that next time. We're going to write the notes. So I'll give you a second, go ahead and write this down. If there's time, we'll just write down as much as we can. That way we don't have to do it next class. Start writing these notes. Give you a second to write them. Again, you can pause the video to help you get it done. And then the assignment's going to be over rotations, not dilations. So if you need more time to write this, just pause the video here. I'm going to move on to the next slide. What we're going to cover, determine if a dilation is enlargement or reduction, or a congruency transformation. A congruency transformation would mean you didn't make it any bigger or smaller. And then be able to find scale factors. The scale factor is how much bigger or smaller you make it, how many times bigger or smaller it goes. All right, you write this down. The scale factor is how much bigger or smaller it is. Usually R is our scale factor, so they'll tell you something like R equals 3. That means you're getting 3 times bigger. These symbols here, absolute values, hopefully you remember from algebra that absolute value means the distance a number is from 0 on the number line. So if I had the absolute value of 7, that's just equal to 7. If I have the absolute value of -3, that's equal to +3, because distance is always positive. And what these rules here say is if your scale factor, if your R is greater than 1, so if it's bigger than 1, you're enlarging the shape. If the absolute value of the scale factor is bigger than 1. So that means it could be a -8. Because the absolute value of -8 is +8. You're still enlarging it. If the scale factor is between 0 and 1, in other words, if it's a fraction or a decimal, so something like 1/5 or 1/2, 1/6, whatever it is. If it's between 0 and 1, the absolute value, it could also be like a -3/4, because the absolute value of that's between 0 and 1. Then you have a reduction. You're making the shape smaller. Enlargement means bigger. Reduction means smaller. If the absolute value of your scale factor is equal to 1, so that means it's either 1 or -1 to start with, the R is, then you're making it congruent. And that goes back to what the first slide said. That's the congruency transformation. That's where the shape's just going to be the exact same size. get down here at the bottom, to decide on something, you just multiply the lengths by the absolute value of R to get the new lengths. So if I start off with a shape like this, and this length right here was 2 inches, then and maybe my scale factor was 3, that means I'm getting bigger. So what I want to do is I want to take, that's 3 and times it by 2. So when it gets bigger, this side now is going to be 6 inches. You could do just the reverse. If they gave you 2 shapes, they told you this side over here was 5, and they gave you another shape, they told you this side was 10, you could, if this was the original and this is the new, you could find the scale factor just by dividing those two. So 10 divided by 5, that gives you 2. Because we were going from the large one, or I'm sorry, we're going from the small one, getting bigger, so our scale factor should be bigger than 1. So you just multiply the lengths by whatever the scale factor is. The side over here was 6 inches. The scale factor was 3. We just take 3 times 6 and get 18 inches on this side. You can find each of those. All right, if R is greater than 0, so this is where it gets a little confusing. If your scale factor is bigger than 0, so if your scale factor is positive, then what's going to happen is P prime, where the new P is located, is going to lie on the ray C regular P. And what that means, if I have C is going to be the point where we're dilating it over. So if I have C there, and P is out here somewhere, then this ray, P prime is going to lay somewhere on that ray. And I know that doesn't make a whole lot of sense right now, but you're staying on the same side of C as the original P was. So if it's positive, you know, your P could come back this way and be in here somewhere. If it's like 1/2, 1/5, something like that. If it's getting bigger, then your P is going to come out in here somewhere, where if the scale factor is making it bigger, your P is going to get farther away from C. I know that doesn't make a whole lot of sense. Hopefully, as we go through it, it'll make a little more sense. If your scale factor is negative, so if your scale factor is negative, then your P prime is going to lie on C P prime. In other words, if this is C, P's out here somewhere, that's our ray going out that way. Well, P prime is going to lay on a ray that's the opposite ray to that. So remember, 2 opposite rays should form a line. 2 opposite rays form a line. So P prime is going to lay over here somewhere. Where up here, P prime is going to lay out here on the same side of C as the original P. So if it's negative, it like goes behind your C there. So it goes this way. So you have negative scale factors and positive scale factors. And you also have to remember all of this stuff where if the absolute value of R is bigger than 1, it's getting larger. If the absolute value of R is between 0 and 1, it's getting smaller. And if it's the same as 1, then it's congruent, so on, so on. So there's a lot to remember here. Hopefully we'll get a chance to do a couple of these, and then it'll make more sense. It's still not going to be easy. All right, if you're on a coordinate plane, so if we have some shape on a coordinate plane, let's change our ink color back to red, and we'll just make up something here. We'll call that A, call this B, we'll call this point C. So we have this triangle, and we're on a coordinate plane. If your scale factor, whatever it is, all you've got to do to find the new coordinates, let's say the scale factor is 3. All you've got to do is take the original coordinates and multiply each one by that scale factor. So A was 4, 4. B was 2, 3, 4, 5, 6, 7, 8, 0. And C was 2, 4, 5, -2. To find the new shape, if our scale factor is 3, our new coordinates, you're just going to take this scale factor, 3, and multiply by each one of these. So 3 times that 4, 3 times that 4, 3 times that 8, 3 times that 0, 3 times that 5, 3 times that -2. That's going to give us 12, 12 for the first one, 24, 0 for the second one, and 15, -6 for the third one. So if I was to try to graph that, which I don't think I have enough space on my thing because I don't have 24 spaces, we would graph those points, and that would have made the triangle 3 times bigger. If we have that same triangle, say we have this same triangle, but this time we're going to change the scale factor, and we're going to make it 1/3. Then instead of multiplying each of these numbers by 3, you're going to multiply each one of them by 1/3. Well, 4 times 1/3 is 4/3, which is 1 1/3. Sometimes when you're doing a reduction, that's what this is, because the scale factor is between 0 and 1, you're making it smaller. When you're doing a reduction, your points don't come out all nice. 4 times 1/3 is 1 1/3. 8 times 1/3, get rid of those. 8 times 1/3. All you do is multiply the whole number times the top, then divide by the bottom. Well, 8 times 1 is 8, divided by 3. 3 won't go into it evenly, but it will go in there 2 2/3 times. 1/3 times 0 is 0. I could have picked an easier number than 1/3. 5 times 1/3. 5 times 1 is 5, divided by 3 is 1 2/3. 5 times -2, or I'm sorry, not 5 times -2. -2 times 1/3. -2 times 1 is -2. Divided by 3 we can't, so -2/3. Those would be our new coordinates. And that shape would be getting smaller. So and this is when we're doing it about the origin on a coordinate system. So our shape would be something like 1 1/3, 1 1/3, it's going to fall somewhere like in there, 2 2/3, and 0 is going to fall somewhere about in there, 1 2/3, and -2/3 is going to fall somewhere about in there. So our new shape, that reduction is going to look something like that. Notice when it was a reduction, it got closer to that point, and that's what's happening when we were doing this. When it's a reduction, it's going to fall in here somewhere. When it's an enlargement, it's going to fall out here somewhere. On this one, if it's a negative scale factor, If it's a negative scale factor, it's gonna fall, if it's a reduction, it's gonna fall in here somewhere. If it's an enlargement, it's gonna fall out here past P prime somewhere. All right, that's the assignment. You probably won't get to that. The assignment I probably actually want you to do is the worksheet. There's a worksheet that's dealing with rotations. And it should say at the top, it says CUDA software up in the left-hand corner, because I got it offline. And it says rotations underneath that. And it has like 6 problems on the front, 6 problems on the back of the first page, and then 4 problems on the third page. So there's about 16 problems, or not, yeah, 16 problems. So hopefully you've gotten that. That will be your assignment. And if you didn't get this far in the video, the sub will know what to give you.